Hello all, welcome to our video this week. Today we got subtracting polynomials. So this is going to be a little bit different than what we saw from adding polynomials last week, but in a lot of ways also very similar. So hopefully that your foundation from last week will help with this quite a bit. So basically for the subtracting polynomials, there's basically 4 steps. One, you're going to distribute the -1 throughout the parentheses that are after the negative. That are after the negative. Okay. Then 2. Step 2. Basically going to rewrite it, and so rewrite the pieces. Rewrite. Step 4, or sorry, step 3, huh? 1, 2, and then 3. Gonna combine like terms. At this point, when you combine like terms, I always would say put it in standard form because I'll save you this last step. Because you want to typically want to write your answer in standard form. And that's basically it. So we're going to go through some examples to hopefully make it a little bit easier for you. For example, we got 4n minus 2 minus 2n. All right, so we're talking about distributing the negative sign. This is it. Here's the negative sign right there. So we don't see 1 in front, so we don't do anything to the front one. But we do see the negative sign back here. So that means we're going to distribute that negative sign throughout. And remember, when there's not a number, you can assume it's a 1. So we're basically multiplying -1 times the inside of the parentheses. So in this case, the top just turns into 4n minus 2. This turns into -2n. Right. So that's our first big thing. Now we got the parentheses are gone, and we're good to go. So now we're going to combine the like terms. We see that 4n, where the n is raised to the 1, the same as this 2n to the raised to the 1. So what that means is you're basically going to do 4n minus 2n gives us positive 2n. And those are used up and done. All we have left is this -2, and there's nothing to combine it with. So it stays -2. And there is our answer. And I started with the highest degree, so therefore it's in standard form already. And technically this is first degree, and there's 2 terms. There you go. It's the first one. All right. Second example. Got 5m plus 3 minus 6m raised to the 3 minus 2m raised to the 2. So, like usual, we're going to first thing we're going to do is distribute the -1 through parentheses. So this is going to be a minus times that one and times the second term. So basically, that means that we're going to change the signs within those set of parentheses. We don't say anything in front of this one, so we just rewrite that one as is, but without parentheses. So the second set of parentheses, because there was a minus sign, we flip the signs on everything that was inside as we pull it out of the parentheses. So now we have 5m plus 3 minus 6m to the 3 plus 2m raised to the 2. Then we look for writing our answer to rewrite it. We first look for pieces to combine, right? So is there anything that are similar? So this m has just a 1 above it, so nothing. This one term does not have a variable. This one has m raised to the 3. This one has m raised to the 2. So there's actually no like terms to combine. So we just need to rewrite it into standard form. So this one is the biggest. So he goes first. And and that's used. Second biggest is the squared, 2m raised to the 2, that's used. Third biggest is the m, just without a number visibly above it initially. And then plus 3 is the last. So there's our standard form answer. And we have 3 is our biggest, so that would be third degree. And we have 1, 2, 3, 4 terms. All right, good job. All right, let's get another example. All right. We got 2z raised to the 3 minus 3z minus 3 plus 2z squared minus 7z minus 1. I just realized, hey, this is not actually what we need to have that be a minus sign to be doing practicing with subtracting differences, right? Okay. So when we do this example of those pieces, we see what we have is nothing in front here, so we don't have to distribute nothing there. We see the minus sign here, minus 1, so we're going to be flipping the sign of that one and times that one. So we rewrite it, 2z to the 3 minus 3z minus 3, and this now becomes a negative 2z to the 2 as we pull it out of parentheses, and a negative times a negative, so it becomes positive, and negative times the negative 1 turns into a positive 1. So we may flip all the signs of the second set of parentheses because there's the negative sign in front of it. Now we look for the biggest pieces. Do we see anything we can combine? Well, first we see the biggest part we have this 2z because it has a 3 above it. This one only has a 1. This one has a 2 above it. This z has a 1. And these other ones don't have any. So the biggest one we have is the 3. So that one goes first. And I don't see any other ones to combine with. So it's by itself. Next we look for the 2's. It's next lowest. This one has the 2. There's no other 2's there to combine. So just rewrite it as is. That's used up. Next biggest is just z with the 1 above, or just z. We have negative 3z and then positive 7. So negative 3 plus 7. Remember, for those pieces, we got negative 3 plus 7z. So that becomes positive 4z. That's right. Because 7 minus 3 is 4. And those are used up. Then we got negative 3 plus 1 goes to negative 2. And that is our answer. And so overall, this would be, because that is the biggest with 3 above it, so we call it third degree polynomial. Oops, you know, be there. And there's 1, 2, 3, 4 terms. All right, good job. One last example. Okay. Got 5u to the 2 plus 3u plus 7 minus u to the 3 plus 2u squared plus 1. Okay. So some idea, we're going to distribute the minus 1 that we got here. So there's a minus sign right there. So that means we're going to change the opposite sign of all these pieces when you pull it out of parentheses. There's nothing in front of this one, so it stays. It's basically, if nothing's there, you assume it's positive. So I pull that out, it's 5u to the 2 plus 3u plus 7. And this other side turns into minus u to the 3 plus 2u. Oh, that's, I'd messed up, didn't I? Because that should turn into a negative. Because this negative 1 times positive 2 turns into negative 2u squared. And then negative 1 times positive 1 turns into negative 1. All right. So now look over all the pieces. Look for the highest number above a letter. So all the ones we got, let's see. This one has a 2 above it. This U doesn't have anything there, so you may assume it's a 1. This term doesn't have a variable at all. This one has a 3 above it. This term has a 2 above it, and this one doesn't have a variable at all. So, make our lives a little easier, we're going to start at the biggest degree. So in this case is a 3. So it goes minus u to the 3 is our first term. That's going to help us put it in standard form. Because remember, standard form, we're going to put the biggest degree first, and then you count down in degrees. Next, we have the squareds. So we got 1 there and 1 there. So that's going to be 5u squared minus 2u squared. And I just put that there to help me do the math a little easier because, you know, so it sort of narrows down my focus on just the pieces that were involved. So 5 minus 2 gives us plus 3u squared. So 5 minus 2 is 3. And that's used up. That's used up. Next, we have just the u here, it's the next biggest degree. And there's no other u's by themselves there, so we just rewrite that. That's 3u, and that's done. And last we have positive 7 minus 1. So 7 minus 1 gives us positive 6. And that is our standard form. Answer, good job. And maybe 3 is the biggest, so that is a 3rd degree polynomial. And we have 1, 2, 3, 4 terms. Remember, the number without a variable does count as a term. All right, good job, guys. And that is our video for the week. If you have any questions, as usual, please let me know. And I'll be happy to help.